This video gives a number of examples illustrating a general solution method for simultaneous equations in two variables. So the previous 5 videos have introduced straight lines and formula for these and shown how you can find the intercepts of straight lines using simultaneous equation techniques and graphs. They also showed a number of examples of how these problems may arise in normal day-to-day scenarios. What we want to do next is be a bit more formal and use the sort of method that students might be expected to use in schools and for exams, and hopefully students will see how these link to the more intuitive methods used in the earlier videos. So what's the general principle? In order to solve simultaneous equations, what we're going to do is remove one variable from the equations, and if we can remove one variable, there's only one variable remaining. So you had 2, you take one away, you've got one left. Once you've got one left, the solution is straightforward. Now, how do we go about removing a variable? So the easiest thing to do is to make part of each equation, and here's the key point, the same. Because if you can make part of each equation the same, then that tells you that those bits are the same, and it also tells you that what's left is the same. So if something is the same in both equations, the other bits must also be the same, even if at first appearance they look different. Now we're going to demonstrate this with several examples, after which we hope it will be clear. So here's the sort of examples we're going to look at. Numbers of simultaneous equations. So you see 2x equals 4y minus 1, 3x equals 2 minus y. Or 5y equals 0.5x plus 4, 2y equals 3x minus 2. Another one here. And you'll see we've put this one in a slightly different format. Whereas in the yellow boxes we've got something equals something. In this pink box we've got 0 equals something, and we've got both the variables on the same side of the equation. And again here, you'll see we've got both variables on the same side of the equation. So what we're doing is showing that simultaneous equations can come in slightly different formats. You also might get something like this. Now what's different about this box is instead of using x and y, we've used w and t. But otherwise, it's still two linear simultaneous equations. Now here's the key point. All of these equations can be rearranged to look the same, to be in the same format. And I would recommend that before you solve simultaneous equations, choose the format you're going to work with and first rearrange the equations into that format. And that will make it a lot easier to deal with. And this is the trick that we're going to use in this particular video. And I should say we're going to use one particular format, but other formats and other methods are possible and may be considered in later videos. So this is what we're going to suggest. You choose a variable, doesn't matter which one, and put it on its own on the left-hand side of the equation. So you want to rearrange the equations so that one variable is on its own. For simplicity, we will put this on the left-hand side. It could be the right, but that's up to you. Now, this is also important to avoid silly errors, which can happen. Ensure that whatever you put on the left has got a positive sign. You don't have to, but it just makes life more reliable. Now, with this particular set of equations here, you can see we've already got x on its own on the left, x on its own on the left. So it's already done. Step 1 is already done, so we don't need to do anything here for these two equations. What about these two? You'll see there's nothing on the left. So you have to decide, are you going to move x or are you going to move y? Now I'm going to move x because it looks somewhat simpler. So what are we going to do? I'm going to end up with 2x equals 1 plus 4y, that's from the top equation, or x equals 4y minus 2, that's from the bottom equation. So you'll see I've now got, as requested, just x on its own on the left, and both those coefficients have got a positive sign. What about the last one? Now this one was written in terms of w's and t's, and I'm going to move the w's. You might want to choose the t's, but I'm going to choose the w. So what do we get? We get 2w equals 4t minus 1 from the top one, or 4w equals t minus 3 from the bottom one. So again, you see, on their own, I've got the w variables and everything else on the right hand side. So that's step 1. Rearrange the equation so they have some form of standard format. Right, step 2. Next, what you've got to do is make the multiplier on the variable on the left the same in each equation. In other words, match the coefficients on the left hand sides so that both left hand sides are now identical. So again, this we can do by example. If you look here, you'll see we've got a 2x and a 3x. If I want to make those identical, I can multiply this one by 3 and this one by 2. And what I will end up with is 6x equals 12y minus 3, and 6x equals 4 minus 2y. And so you notice the multiplier is such as to make the left hand side the same. So that's step 2, make the left hand side the same. What about this one? I've got 2x equals 4y plus 1 and x equals 4y minus 2. So I don't need to change the first one. All I need to do is multiply this bottom one by 2. And then I'm going to get 2x equals 4y plus 1. Nothing's changed there. And on the bottom one, 2x equals 8y minus 4. Okay? And the last example. I've got 2w equals 4t minus 1, 4w equals t minus 3, so I can multiply the top one by 2, and then you'll see the top equation becomes 4w equals 4t minus 1, and the bottom equation was already a 4w equals t minus 3. So you'll see the secret that we used. Oh, and I've done a silly typo there. I forgot to multiply this bit by 2. 2 times 4t minus 1 is 8t minus 2. There we go. So you'll see in all cases we've now made sure the left hand sides look the same. Right, step number 3. As one side of the equation is the same, then the other sides must also be the same. So these two are the same, so that means that this value must equal this value. So now I can solve. So I can write 12y minus 3 equals 4 minus 2y, which gives me 14y equals 7, or y equals 0.5. What about this next one? You see these two x's are the same, so that means this value must equal this value. So I get 4y plus 1 equals 8y minus 4, or moving things to the same side, I get 5 equals 4y, or y equals 1.25. And for the last example, again, you see I've got 4 w's on the left, so this term must equal this term, and if I solve that, I get 8t minus 2 equals t minus 3, which gives me 7t equals minus 1, which gives me t equals minus 1 over 7. Final step then. Now that we've solved for one variable, we can use that in one of the other equations to solve for the other variable, and then use the remaining equation as a check. So let's do that first for this example. So we've got y equals 0.5. Let's first of all substitute this into the top equation and see what we get. So 6x equals 6 minus 3, which equals 3, and this implies that x equals 0.5. Having done that, the next thing is to do the check. So let's try this equation here. So we go 6x equals 4 minus 2y, and put in your two values. X is a half, y is a half, and you get 3 equals 4 minus 1, which checks. So you've now solved this particular set of equations. Next one. we've got y equals 1.25, so let's substitute that in the top equation to solve for x. So 2x equals 5 plus 1 equals 6, which tells me that x equals 3. Next, use the second equation for your check. So 2x equals 8y minus 4. Put the values in. 6 equals, now 8 times 1.25 is 10, minus 4, and it checks. Next example. Okay, here we had t equals minus a seventh, but again we're going to use the same trick, and what we're going to do is put this value in the top equation and see what we get. In fact, no, I'm going to just change this a bit. I'm going to use the bottom equation. You have a choice. So I've got 4w equals minus a seventh minus 3, which gives me minus 22 over 7. And therefore, dividing through by 4, I get w equals minus 22 over 28. Not a very nice answer, but it doesn't really matter. It's only algebra. And now, what I do is put these two solutions in the top equation, the one I haven't used, to see does it indeed work. So 4w is going to be minus 88 over 28, and then we've got 8t, which is minus 8 over 7, and then minus 2. Does this match? Well, the thing to do is to multiply through by 28 and then check. So I get minus 88 equals minus 32 minus 56. And you'll see indeed it checks. Okay, we'll do a few more examples, going through all the steps on a single page to see what's happening. So what have we got? We've got x equals 10y minus 17, 4x equals 8 plus 2y. So what was the first step? The first step was to make sure you had a variable on its own on the left hand side. Now we've already got that. X is already on its own on the left hand side, so I don't need to do anything. Step 1 is as it is. Step 2 was to make the coefficients on the left hand side the same. Now I can do that by multiplying this top equation by 4. So what I'm going to get is 4x equals 40y minus 68, and the other equation I don't need to change. 4x equals 8 plus 2y. And you'll see now that what we've got on the left is the same, which means I can equate the other two parts. So in step 3 I've now got 40y minus 68 equals 8 plus 2y. And if I now join things together and see what we've got, we're going to end up with 38y equals 76, which tells me that y equals 2. Okay, and finally we've got to substitute those in to the original equations and see does it work, or substitute it in. So let's first of all take the top equation and solve for x. So x equals 10 times 2, which is 20, minus 17, which is 3. So our proposed solution is y equals 2, x equals 3. Let's substitute it into this last equation just to check it works. So 4 times 3 is 12. Check it against 8 plus 4, and it works. And perhaps for the examiner's benefit, write that you're doing a check there so they know what you're doing. So we've got our solution, y equals 2, x equals 3. Next question, and you'll see this one I've put the equations in a slightly different format. So now you have to decide which variable are you going to bring on the left. Now looking at the z's and the w's, I think it's easier to bring these z's to have the same coefficient than the w's, so I'm going to pull out the z's. So what I'm going to get is 4z equals 8 plus 2w for the top one, and 2z equals 7w minus 20 for the bottom one. And now what do you see? On the left hand side we've got the same variable, both with positive coefficients, because that makes my life easier. Next, make those coefficients the same size. So I'm going to multiply this one by 2. So I get 4z equals 8 plus 2w, and 4z equals 14 minus 40. So now you can see I've got what I wanted. The coefficients here are the same, the left hand sides look the same. So now I can equate the right hand sides. So I get 8 plus 2w equals 14w minus 40. And now if I bring common terms together there, I'm going to get 48 equals 16. Sorry, not 16. My algebra's gone wrong there. Not 16, but 12w. And so that tells me that w equals 4. Now, having got w, I need to solve for z. So let's try substituting into one of these equations at the top. So 4z equals 8 plus 2w equals 8 plus 8, and this tells me that z must equal 4. And finally, I can check that in the second equation just to see that things work. So for example, 2z equals 7w minus 20, and I should write again that I'm now doing my check. So substitute the numbers in. 8 equals 28 minus 20, and it works. So in summary, we've demonstrated a general approach to solving linear simultaneous equations. So they're equations a bit like the ones in the top right here. Step 1, rearrange the equations so that one variable is on its own. And in simplicity, we've demonstrated that here. Bring one of the variables onto the left-hand side, make it on its own. And to avoid silly errors, we recommend you ensure that both the coefficients have a positive sign. Step 2, match the coefficients on the left-hand side so that both the left-hand sides are identical. Step 3, you can then equate the right-hand sides. And having done that, you've solved for one variable, and we can substitute that into one of the equations to find the other variable, and then use the second equation to check you haven't made any silly errors.